Hi everyone, welcome back to ICS 111, Intro to Computer Science 1. In this video, we'll be continuing our look into loops and introduce variable scope. The first thing that we will look at is definite and indefinite looping. These are approaches or situations and not specific types of loops. Specific types of loops would be while and for, but definite and indefinite are approaches. We'll revisit loop-related concepts and introduce a new one called sentinel value. Then we'll introduce another loop, the do loop, which is essentially an upside-down while loop. And then finally, we'll talk about nested code and variable scope. That is, identifying where in your program a variable can be used. This is important because our programs will start to become more complex as we start to nest code. To start the lecture, we'll look at definite and indefinite looping. Definite looping is when the number of iterations is known and there is some way to get that information. For example, if you want to loop 5, 10, 100, or some arbitrary number of times without interruption, it is best to use a for loop. So you want to go from start to end without interruption. Versus an indefinite loop. An indefinite loop is when the number of iterations is unknown and there is no way to get that information. So for example, if you create a program that keeps on running until the user wants to quit, there is no way to know how many times the user wants to run the program until they quit. Another example is if the program starts to do some error checking on the input. If there is something wrong with the input, we would want the program to re-ask the user. But when you start to re-ask the user for new input, there is no way to know how many times it's going to take for the user to enter valid input. For those types of situations, it is best to use a while loop. For either of these two situations, definite or indefinite, you can actually use either type of loop, but knowing when to use each will simplify the coding process. It is similar to knowing when to use a switch case and when to use else-if statements. Here's a food for thought question. Take a few seconds and pause the video. Is looping through each index in a string, is that considered definite or indefinite looping? It would be considered definite looping. The number of iterations to loop through each index in a string is not unknown. The number of indexes in a string varies, but the indexes are based on the length, which can be retrieved using the length method. If there was no way to get the length of the string, then maybe it would be considered indefinite looping. So there is some way to get that information. Therefore, the number of iterations is known. Alright, so we have definite and indefinite looping. For definite looping, that is when the number of iterations is known and there is some way to get that information. It is best to use a for loop. For indefinite looping, that is when the number of iterations is unknown and there is no way to get that information. It is best to use a while loop. The loop examples that I have shown you in the previous lectures are actually definite looping. Those were all looping in arbitrary amount. So really, the new thing is this idea of an indefinite loop. To further explore this approach of an indefinite loop, we will need to revisit loop-related concepts. So recall the two loop-related concepts that we have seen already, counter and increment variables and accumulator variables. An increment variable is used to keep track of a count, and an accumulator is used to keep track of a sum. The analogy that I used is the grocery analogy. You go to the grocery store, you buy some items. How many items you bought, that is kept track with an increment variable. The total cost that you pay, that is kept track using an accumulator variable. Now the new loop-related concept is this thing called a sentinel value. A sentinel value is a special value that is used to terminate a loop. It is a value that is outside the range of valid input that has a special meaning. The presence of a sentinel value guarantees the termination of a loop. A sentinel value is also called a flag value or signal value, and it is often used in indefinite looping because in indefinite looping, the number of iterations is unknown. So if the number of iterations is unknown, how is the loop supposed to stop? And it stops with this sentinel value. As an example, when faculty enter grades at the end of the semester, if there are any failing grades, the faculty person must enter a date of last attendance. And the faculty actually cannot submit failing grades without the last date of attendance. But the situation is that what if the student is a ghost student, meaning they have never attended class? Putting a date within the semester would not make any sense because that would imply that the student attended class on that date. So what the faculty have to do is enter the date right before the semester starts. And that is a sentinel value that allows the submission of grades. So when the faculty have to enter failing grades, they have to put a date of last attendance. But if the student did not attend class at all, putting a date within the semester would not be correct. So we use a special date right before the semester starts is outside the valid range that has a special meaning. And it means the student has never attended class. And that is the sentinel value. To get a handle for definite and indefinite looping, let's do some examples. To showcase the differences between definite and indefinite looping, I'll be creating two programs that adds numbers from the user. The difference in approaches can either limit or expand the functionality of the program. For the first example, I'll be using a definite loop to add numbers from the user. A definite loop is used when the number of iterations is known and you want to go from start to finish without interruption. It is best to use a for loop. For this program, it's called definite add numbers. I've already set up the program skeleton and imported the scanner. If you want to follow along, pause the video and set up the program skeleton you see. Since we're using a definite approach, this program will be asking the user the same amount of numbers each time the program is run. The number of iterations will be known. Since we'll be adding numbers, we'll need a variable to temporarily store the number the user entered. We'll be using the double type for this, so the user can enter an integer or a number with decimal. We'll call this variable input double, and I'll initialize it to 0. So when the program is getting the user input, this variable will be used to temporarily store that value. What we'll be doing with that value is accumulating it. So we need another variable to keep track of the running total for the numbers that the user is entering. We'll need a double variable since we're going to be adding doubles, and we'll call this sum of doubles. This will be our accumulator variable, and we'll initialize it to 0. Now in a definite loop, the number of iterations is known. So how many numbers is this program going to be asking the user? We'll create a variable to represent that amount. How many? That's usually an integer. So we'll use an int and we'll call this max doubles. And let's go ahead and initialize it to 5. So whatever value that this variable is assigned or initialized, that's how many numbers the program is going to ask the user to add. Since we're getting user input, we'll need to create our scanner. Scanner reader equals new scanner system.in. And then we'll tell the user what this program does. I'll use a printf for this. So I'll do system.out.printf, add an integer amount numbers. We'll keep it short and simple. So add some number of integers and we'll say max doubles. Now, if you notice, I'm putting the printf after my variables. In the other examples, I had my printf right at the beginning, But because the printf is referencing the max doubles variable, I need to have the variable declared and initialized first. What's nice about doing it this way, since the printf is relying on a variable, now if this value changes, then the message to the user will also change. So let's go ahead and compile to make sure it's valid syntax, and then run to see what that looks like. So my output message is add 5 numbers. And if I were to change this variable, let's make it 7, recompile, and run, then now the output message is add 7 numbers. Since the printf is using the max doubles variable, whatever value that this variable has, that will be the output. All right, I declared and initialized some variables. I have my instructions to the user. Now it's time to actually get the user input. Since this program is using a definite approach, we're going to be using a for loop. A for loop is best for definite looping when you want to go from start to end without interruption. So here's how we're going to be getting the user input. After the instruction to the user, I'll give myself some working space, and then I'm going to start the loop because the loop will contain the code that we want to repeat. The code that we want to repeat is asking the user for input, getting that input, and accumulating it. It will look like this. We'll start the for loop. For int I equals 0, and the condition will be I strictly less than max doubles. Recall the pattern. If you go from 0 to strictly less than some limit, the loop will iterate limit many times. So if we go from 0 to strictly less than max doubles, the loop will iterate max doubles number times as long as we increment that variable I by 1. So we'll do I++. We'll close the parentheses, and then we'll start our opening and closing curly bracket. Now at this point, you should try and compile. Compile your code now, because if it doesn't compile now, it won't compile later. All I did was just create a for loop that will iterate max doubles many times. It compiled okay, and if I run, then I just get that output message, add however many numbers. The loop does execute, but because there is nothing in the body of the for, nothing happens, or at least nothing visibly happens. So what do we want to do at each iteration of the loop? At each iteration, we want to ask the user for the number, get it, and then accumulate it. Okay, we're doing these 3 things over and over again, asking the user for input, getting it, and accumulating it. When you start to work with a loop, you have to think of the first instance. What is it that you're having the loop do over and over again? The purpose of the loop is to repeat code. So what is it that you're trying to repeat? We want to repeat asking the user, getting the input, and accumulating. And that happens all in the loop. So in the loop, I'll place my cursor in the for, and then I'll do a couple spaces to indent. Now we're going to ask the user for the number. We only want to do it once because the loop will repeat, and that's how the program will ask again. So we'll do a printf. We'll do system out printf. And for the prompt, let's show the user the iteration that they are on. What do I mean by that? Well, I'm going to do this. For the format string, I'll do %d, space, and then quotes, comma, I. So at each iteration of the loop, the user can see, okay, what number am I up to? If we're asking the user to enter 7 numbers, it would be good to know which number they are on when they are entering it. So let's see what that looks like. If I recompile and then run, then I can see, okay, 0, 1, 2, 3, 4, 5, 6. So 0 to 6, that is 7, but if we're asking the user to enter in some numbers, entering 0, 1, 2, 3, 4, 5, 6 may not make sense to a typical user. What would make sense is 1, 2, 3, 4, 5, 6, 7. So what we want to do is offset this variable I. We want to offset it by 1, but we only want to do it for display purposes. It is still going to be internally 0, 1, 2, 3, 4, 5, 6, but what the user sees will be 1, 2, 3, 4, 5, 6, 7. So we will offset the output by 1. So this I plus 1 here, that is for display purposes only. It doesn't change the value of I because there's no reassignment. The only reassignment happens in the modification, I equal I plus 1. So the I plus 1 here in the printf, that is only for display purposes. It will offset it by 1. So let's recompile and run to see what that looks like. And we can see there, 1, 2, 3, 4, 5, 6, 7. Now, you may think at this point, it looks weird that it's all on one line, but remember, we're going to get some user input. When the user types a number, they're going to hit enter. So that will give us that new line and separate each line of input. Let's come back to the for. So now we have our prompt. Now let's get the user input. After the prompt, we'll take our temporary variable, input double. This is where we will temporarily store the number that the user entered. So we'll do input double equals reader.next double. So the program will get the number. And what do we want to do with that number? We want to accumulate it onto sum of doubles. So the accumulation is going to look like this. Sum of doubles equals sum of doubles plus input double. So this line, sum of doubles equals sum of doubles plus input double, that is going to accumulate all the doubles or all the numbers that the user entered, and it's going to keep on reassigning this variable sum of doubles. Recall how the assignment statement works. The right-hand side needs to execute first, and then the result of the right-hand side is stored on the left. So whatever the current value of sum of doubles is at this point of the execution, it will be added to input double and then reassigned to sum of doubles. And that is how the accumulation happens. So these three things, we only have it one time because the loop is going to repeat these instructions a definite amount of times, which is max doubles. So the assumption is the for loop is used to get the user input. After the for loop, which is down here, after the for loop, when the for loop exits, that means the program is done asking the user for input. Okay, this is important to note. After the for loop, the program is done asking the user. So if the program is done asking the user, what do you want to do? In this case, we want to output the result of sum of doubles. So we will do system out printf, and I'll do sum equals %f%n for the new line, and then I'll do sum of doubles, just like that. So after the program is done asking the user, we want to output the sum. You don't want to output the sum inside the loop because inside the loop, the program is still asking the user. You want to wait until after the program is done asking the user for information, and that is after the for loop. I don't want to enter 7 numbers because that seems like a lot. Let's change this to 3. So it's a relatively small amount and we can verify. So let's recompile and then run. All right, so it says add 3 numbers. Number 1, let's do 1. Number 2, let's do 2.2. And for number 3, we'll do 3.3. Hit enter. And so that'll exit the loop. So this input here, 1, 2, 3, that is part of the loop here inside the for. So 1 plus 2.2 plus 3.3, that should give you 6.5. If you whip out your calculator, you can quickly verify. Now, if this seems like a lot to take in, the setup of this program is actually no different than what we have seen. I declare and initialize my variables. I tell the user what to do. I get the user input, and then I output the results. Okay, it is still the same basic outline. Declare and initialize variables, tell the user what the program does, get the user input, and output the results. It is still the same flow. What you need to understand is that since we are using a loop to get the user input, that is inside the loop. So notice I didn't copy and paste this code 3 times to ask the user for 3 numbers. I only have this set of instructions 1 time because these lines of code will repeat at each iteration of the loop. So I only have it one time. Even though you only see it one time in the code, the fact that it is in a loop means that it is going to repeat. Now, coming back to this definite versus indefinite, this is a definite approach to add numbers from the user. This program is always going to be asking the user the same amount of numbers. Since I've declared max doubles as 3, if I run the program again, it's going to ask the user for 3 numbers again. So if I type out 3 numbers, hit enter, then it exits the loop and then it outputs the sum. So it goes from start to finish without interruption. I cannot add any error checking. If I were to add error checking, that will essentially interrupt the loop and ruin the approach. So for things like counting from 1 to 10 or looping an arbitrary amount, going from start to finish without interruption, that is a definite approach, and you would use a for loop. I cannot add any restriction on the number the user enters, otherwise that will ruin the definite approach. So in this example, we did a definite loop to add numbers from the user. The amount of iterations is known, and we go from start to finish without interruption. Let's move on to the next example. In this example, we'll be using an indefinite loop to add numbers from the user. An indefinite loop is used when the number of iterations is unknown and there is no way to get that information. Usually, there is some error checking and re-asking the user is involved. It is best to use a while loop. In this example, we'll be using an indefinite loop to add positive numbers, as many numbers the user wants. So we do not know how many positive numbers the user is going to enter, but we're going to be accumulating all of those numbers. Now, compared to the previous example, definite add numbers, we could do any type of number. We could do positives and negatives, but it is always the same amount. In this example, we'll be adding positive numbers as long as the user wants to. We do not know how many positive numbers the user will want to enter. So if we don't know how many positive numbers the user is going to enter, how do we stop the loop? And that is where a sentinel value is used. A sentinel value is used to terminate a loop. The presence of the sentinel value guarantees the loop will terminate. If you want to follow along with this example, pause the video and create the program skeleton for indefinite add positives. Let's start by telling the user what this program does. These instructions are not dependent on any variable, so I'll go ahead and output the instructions. I'll do a system out println, and we'll say add any amount of positive numbers. Type a number, then hit enter. And then for the last line, to stop, enter -1. The -1 will not be added. So this -1 here, this is going to act as a sentinel value so that when the user does hit -1, that means the user wants to stop adding numbers and we will output the result at that time. All right, so to reiterate what we're doing, this program will be taking in numbers until the user wants to stop. We do not know how many numbers the user wants to add, so we need to use an indefinite approach. The sentinel value for the indefinite loop is -1. When the user enters -1, we want to stop the loop and output the results. Why not? Let's go ahead and compile and then run the program to see what that looks like. So if I move this up a little bit, add any amount of positive numbers, type a number, then hit enter. To stop, enter -1. The -1 will not be added. Okay, so that looks good. Now let's come back to the program and let's make our variables. Since we're asking the user for some numbers to add, we will use similar variables from the previous example. We need a temporary variable to store the user input. So I'll have input double and I'll initialize it to 0. We need our accumulator variable, which is sum of doubles, and I will initialize it to 0. Now, in the previous example, in definite add numbers, the next variable that I created was how many numbers to add. Now, since in this program, the user can add as many as they want, I'm not going to have max doubles here, but I actually want to keep track how many numbers that get added. So for this variable, I'll have an int, but I'll call it num doubles. Okay, the num doubles, this variable is going to keep track of how many numbers actually gets added because the program only adds positive numbers. Any negative numbers will be ignored, and specifically -1 will terminate the loop. Since we're asking the user for some input, we'll create a scanner. So scanner reader equals new scanner system.in. And why not? Let's also compile at this point. Compile at small steps to make sure that you're making valid Java code. And here comes the hard part. We are going to make an indefinite loop, a loop that keeps on iterating until the user wants to stop. We do not know when the user wants to stop, but we do know that if they enter -1, then we want to stop. For my indefinite loops, this is how I set them up. I know I'm going to be using a while loop, but how do I know what's my initialization, condition, and modification? What about those 3 components of a loop? This is how I approach indefinite looping. Because we do not know how many times the loop needs to iterate, I am going to create a Boolean variable that represents if the program should keep asking the user. So after my scanner, I'm going to create a Boolean variable. So I'll do Boolean, and I'm going to call this variable keep asking, and I'm going to assign it the value true. So this variable, keep asking, this is going to represent if the program should keep on asking the user. As long as this variable is true, the program will keep on asking the user. So I'm going to use this as my initialization. So Boolean keep asking equals true, and then I will start the loop. I'll do while, and my condition is that same variable, keep asking. So while keep asking is true, the program will keep on asking the user for some input. I know the loop will execute because I initialized keep asking to true. So I know this is going to be true and the body of the while will execute. So I have my initialization and I have my condition. I'm going to hold off on the modification for now, but inside the loop, okay, what is it that we want to do inside the loop? If we take a look at the definite add numbers, we can kind of get an idea of what we want to do. In the definite add numbers, we had a prompt, we got the user input, and we accumulated. So those 3 things is what we want to do in the loop as well. Have a prompt, get the user input, and accumulate. But there is an added layer. There's an added layer of add positives. We only want to add positive numbers. So keep that in mind. The first thing that we're going to do in the while loop is get the user input, because we need to get something first. We don't know if the user actually typed a positive number or not. We need to get the user input. So inside the while, I will have the prompt. I'll do system out print, and because this is an indefinite loop, we don't know how many times the user is going to enter in numbers. I'm just going to use a generic angle bracket here. So the angle bracket will act as the prompt symbol. So I'll do an angle bracket, and then I will get the user input. Input double equals reader.next double. Okay, just like that. All right, so we have this. Now I want to see how this runs. I haven't done anything else yet. I just added a prompt and get the user input. So let's compile and then run. Okay, and I get my message. So on the prompt, if I do 1, hit enter. If I do 3.14, hit enter. If I do -9 and hit enter, then it keeps on asking. So if I keep on entering numbers, then it keeps on going on and on and on. If I do -1 and then hit enter, oh, it's still asking me. It's still giving me the prompt. So I want to make sure that the loop ends. What I'm missing is the modification. I have my initialization, I have my condition, Now I need my modification. The modification is something that eventually makes the condition false, but since my condition is a Boolean variable, the modification will make the condition false because I need to make sure the loop terminates. Right now, the program keeps on going if I keep on adding numbers. So I need to make sure the loop terminates. Right now, I'm stuck in an infinite loop. If you are stuck in an infinite loop, then use this end button here that you see on the bottom, and that will end the current run of the program. Even if it is stuck in an infinite loop, you can always hit end. Okay, so now, before I even do any type of accumulation, I need to make sure the loop terminates. I have this sentinel value -1, so I need to check if the user entered -1, then I want to stop the loop. So it's going to look like this. Okay, after the program gets the user input, okay, it needs to be after because the program needs to receive something from the user in order to determine what to do. So after the program gets some information, we need to check it. So I'll use an if statement. If input double, if it is -1, okay, that is going to be the sentinel value. If input double is -1, that means the user is done typing in numbers and they want to quit. So if the input double is -1, then this is where the modification happens. Keep asking equals false, and that's it. So when the user enters -1, keep asking will be set to false, and therefore when it comes back up to the top here, keep asking will be false, and therefore the loop will not iterate again. So let's go ahead and test this out. Okay, all I did was add an if statement. I added it inside the while loop. So let's go ahead and add a comment here. So I'll say closes while, and this one closes main, and the last one closes class. All right, so let's go ahead and compile and then run. Add any amount of positives. Okay, I get my instructions. Now let's see what happens if I do -1 right off the bat. Hit enter, and good. The program stops. It doesn't ask again. I do not get an angle bracket. The program just ends. So when keep asking is set to false, the loop terminates and any code after gets executed. But since there is nothing after the while loop, the program will just end as normal. But this is good. This ensures that when the user does enter -1, then the loop will stop. Okay, this is important. I haven't done any accumulation. I haven't done any testing if the number is actually positive. I'm just making sure the loop terminates. Once you ensure the loop terminates, then you can start to add more layers to your program. Now this program is indefinite add positives. So we only want to add positive numbers. We get the user input and then we start to check it. If it is -1, the user wants to stop, so we set keep asking equals false. What happens if the user does not enter -1? That's where we're going to be using an else if. So after the if, we will have an else if. Okay, the else if will evaluate if the previous condition was false. So what happens if the user does not enter -1? What do we want to do? Well, since the program only adds positive numbers, we will check if that number is actually positive. I'll do input double greater than or equal to 0. So if the user did enter a positive number, we want to accumulate it, and we also want to increment this variable num doubles. So just as what we did in definite add numbers, to accumulate, we will do sum of doubles equals sum of doubles plus input double. Notice this is the accumulation. It is the same accumulation as definite add numbers, but this accumulation is inside this if. It only executes if input double is greater than or equal to 0 because we only want to add positive numbers. If the user entered -1, then we want to stop the loop. If the user entered a number greater than or equal to 0, then we want to accumulate. In addition to the accumulation, let's go ahead and increment num doubles as well. So we want to know how many numbers actually got added. So this condition, input double greater than or equal to 0, it will only be evaluated if this condition was false. So if the user did not enter -1, then the condition down here will get evaluated. Now, what happens if the user enters something like -1000 or -2 or -100? What do we want to do? At this point, if the user does enter -100, it's not going to matter because the accumulation and increment only happens when the input double is greater than or equal to 0. So what do I mean by that? Well, let's continue on with the program. After the while loop, that means the program is done asking the user. The user had entered -1 and therefore the loop exited. So after the while, the program is done asking the user. So what do we want to do when the program is done asking the user? We want to output the results of the accumulation and how many numbers were added. So after the while, we will print the results. System out printf, and we'll do the same thing. So sum equals %f %new line, and that is sum of doubles. And we'll also print out how many doubles that were added. So numbers added equals, this is an integer because num doubles is an integer variable. And that will be num doubles here. And then let's also output a message, done. All right, so let's recompile and then run. Add any amount of positive numbers. Okay, so let's do -1 again right off the bat. I'll hit enter. So sum is 0. Numbers added 0, done. Okay, that's expected. I didn't enter any positive numbers, so this is looking good. If I run again, so if I do 1, 2, 3, and then -1, hit enter. So sum is 6, and the numbers added is 3. So 3 plus 2 plus 1, that is 6. Notice the -1 is not added. So the numbers added is only 3. Which is the 1, 2, and 3, and the sum is 6 and not 5. Now, if I run again, I can keep on entering numbers. I can add an arbitrary amount of numbers, and the program will still keep on asking the user. Only until the user enters -1 will it stop asking and then print the results. So sum is 97.94, and the numbers added is 11. Now let's see what happens if I enter some negative numbers. So let's run the program again. So let's do 1, -2, 2, -3, and then -1. Okay, I'm not going to hit enter yet, but let's take a moment to see what should happen. Since the program only looks for positive numbers, I will expect 1 plus 2 will be 3, and the numbers added should be 2. So I expect the output to be 3 and 2. These negative numbers here should be ignored, and the -1 is the signal to stop asking. If I hit enter, then, oh, there we go. The expected output, the sum is 3, which is the 1 plus the 2, and the numbers added is 2, which is the 2 numbers. If I run again, if I do -6, -9, -10, -7, and then let's do -1, hit enter, then sum is 0, numbers added is 0. All of the numbers that I entered were negative, so it did not satisfy this condition. Therefore, the accumulation and the increment did not happen. Now, at this point, I want to give some feedback to the user that there's something wrong with what they entered. Because if you're continuing entering numbers like this without any feedback, then the user may assume that it is accumulating those numbers. So if the user is entering negative numbers, let's give some feedback. What we're going to do is come back to the if statement, and then we'll add an else clause. Okay, we'll add an else because we've already compensated for all the other values. The specific value of -1, positive values, and the only other values left are invalid, which are negatives. So that will be the else clause. Because if the user did not type in -1, they did not type in a positive number, therefore they typed in a negative number. If they typed a negative number, then let's give an error message. I'll do system out println, and then I'll say error, let's do some helpful feedback. We'll say error, and then we'll say that number that they typed is not a positive number. So if the user does type in a negative number, we'll output an error message and we'll tell them specifically the number that was wrong. So let's recompile and then run. So if I do -9, hit enter, then I get the error. -9 is not a positive number. If I do 1, 2, 3, I don't get any error message. So the assumption is that the program is accumulating those numbers. If I do -7, -100, -1000, then I keep getting those error messages and those will not get accumulated. If I do -1, hit enter, then the loop exits and I get my results. Sum is 6 and numbers added is 3. So if I look back at the run here, the only numbers that were positive were the 1, 2, and 3. So that adds up to 6 and that's a total of 3 numbers. So this indefinite, the user can keep on entering numbers until they want to stop. We do not know how many numbers the user wants to add. So we need to use an indefinite approach. And how that is accomplished is I use this Boolean variable, keep asking. As long as this variable is true, the code in the loop executes over and over again. But in order to ensure the loop exits, there needs to be a sentinel value. The sentinel value guarantees the termination of the loop. And in this case, the sentinel value is -1. In any indefinite loop, there needs to be a sentinel value. Otherwise, the loop cannot terminate. But this allows the flexibility of an indefinite amount of iterations. It still uses the same 3 components: initialization, condition, and modification. The while loop is used to get the user input, and it will keep on iterating as long as the user wants to enter in numbers. After the loop, it is assumed that the user is done giving input, and therefore we want to print the results. You do not want to do any of these things inside the while because the while loop is used to get the user input. After the program is done getting the input, then you output the results. If you are having trouble following along with these examples, it is posted on Lalima. I recommend that you do try them out. Maybe rewatch these examples and try to follow along. Let's go back into the slides and continue on with the lecture. For this next part of the lecture, we'll introduce a do loop, also called a do-while loop. A do-while loop is a while loop whose body executes first, then the condition is evaluated. This means the body of the loop is guaranteed to execute at least one time. This is useful when you want to ensure the body of the loop executes at least once. If you take a look at the flow diagram shown on the slide, you can see that it is an upside down while loop. So the statements execute first, then the condition is evaluated. If the condition is true, go back to the top of the do, execute the statements, re-evaluate the condition, and that is where the loop happens. As long as the condition is true, go back up to the top of the do, execute the statements. When the condition is false, then the loop exits and the program continues execution as normal. Taking a look at the syntax of a do-while loop, it really is an upside down while loop. You have a do block, which is the body of the loop, and that's why it's called a do loop. Then after the closing curly bracket, you have the while. That is why I put the while reserved word next to the condition in the flow diagram. Recall that program flow is from top to bottom. This is why the loop will iterate at least once. The flow of execution starts at the do and then goes into the body of the do, and the statements will execute. After the statements execute, then the condition is evaluated. If the condition is true, then the flow of execution will go back up to the do and re-execute the statements in the body. Note the use of 2 reserved words, the do and the while. you have a do block and then the while condition. Also note that the condition ends with a semicolon. This is somewhat peculiar, but necessary. When I introduced the while loop itself, I mentioned that you should not put a semicolon after the condition. That was a common mistake. But in a do loop, you must have a semicolon after the condition, and that will properly end the do while loop. With any loop, you have the three components: initialization, condition, and modification. The placement of the condition is as we would expect in the parentheses. But what about the initialization and modification? It is the same as a while loop. Initialization is outside above the do. Modification is somewhere inside the body of the do, typically at the bottom. Here are some common mistakes when working with a do loop. If you declare the loop increment variable inside the do, the program will not compile. This has to deal with variable scope, which we will talk towards the end of this lecture. If you initialize the loop increment variable inside the do, the condition will not become false because the variable will always go back to the initial value. The state of the loop increment variable is essentially reset, rendering the modification useless. As an example, let's say you want to print the numbers 0 to 4 and show I is changing at each iteration of the loop. So I equals 0, I equals 1, I equals 2, etc. The loop on this slide will not pass the compiler. It will say error, cannot find symbol, and if you read the error message carefully, it's going to have a caret at the I. So Java is going to tell you an error, and it's going to say it doesn't know what this variable I is. Because the variable I was declared inside the do block, I can only be used up to the closing curly bracket, and this applies to any variable that you declare inside the do block. You will only be able to use it up until the closing curly bracket. After the closing curly bracket, I does not exist, which it is needed because it is used in the condition. Since it's been declared inside the do, you can only use it inside the do. To correct this, you would place the initialization in its proper place, outside above the do. So int I equals 0, and then the do block and what you want to do as part of the loop. So I have the table on the side here to demonstrate what happens at each iteration. So I is initialized to 0. So when the do block enters, it'll execute the printf. The first time the loop executes, I is 0. So it will print I equals 0. Then I is incremented by 1. And then the condition is evaluated. Is I less than 5? Yes, it is. So go back up to the do block, print I equals 1. Then the modification, I becomes 2. Evaluate the condition. Is 2 less than 5? Yes, it is. Go back up to the top, print I equals 2. Then increment, I becomes 3. Is 3 less than 5? Yes, it is. Go back up to the top of the do. So this continues until the loop evaluates to false. Try not to be confused here. If you take a look at how many times the condition evaluated to true, the table indicates 4 times, but the body does iterate 5 times. The code in the body of the do executes 5 times when I is 0, 1, 2, 3, 4. Although the condition evaluated true 4 times, the body executes first, then the condition is evaluated. I recommend that you try this example for yourself to get a concrete feel for it. So this was one common mistake, having the declaration inside the do. If you put the declaration inside the do, your program will not compile. It needs to be declared outside above the do. Another common mistake is having an initialization inside the do. So let's say I was properly declared outside above the do, but this is an infinite loop. Note that I is being assigned the value 0 at the beginning of the do block. This will essentially interfere with the modification. The modification of I++ is trying to increment I so that I will eventually reach 5 to make the condition eventually false. As you can see in the table, what is always going to print is I equals 0. I increments to 1. Is 1 less than 5? Yes, it is. Go back up to the top of the do. You have the I equals 0. So it's always reassigning 0 to I, and it's interfering with the modification. So this is an infinite loop. To correct this, remove the 0 assignment. Only the modification should reassign that increment variable. So this will iterate 5 times. Just as we've seen from before, even though the condition evaluates true 4 times, because the body executes first, the body executes a total of 5 times. As an FYI, the placement of the modification within the body can yield different results. This was the off by 1 common mistake that was mentioned in a previous lecture. So you can see the 2 do loops on the slide. The left side prints 0 to 4, and the right side prints 1 to 5. It is essentially the same loop, but the modification is in different places. On the left side, the modification is at the bottom, and on the right side, the modification is at the top. Typically, the modification is placed at the bottom to ensure consistent behavior. If you initialize your increment variable to a certain value, for example, 0, then you would assume that I would be 0 during the first iteration of the loop. But if the first thing that the body of the loop is incrementing the variable, then that can throw off the increment by 1 if you are actually doing something with that variable I. You might as well have initialized I to 1 in that case. So we have looked at 3 types of loops: for, while, and do. In terms of evaluating the condition, in a for and while loop, the condition is evaluated before the body of the loop. This means that the loop may or may not execute at all, but in a do loop, the evaluation of the condition is after the body of the loop. And this is why it executes the body at least once. In the grand scheme of things, these are just different types of loops that you can use in your program. Knowing when to use these loops can simplify the coding process. If you're doing some definite looping, use a for loop. If you're doing some indefinite looping, use a while loop. If you need to guarantee that the body of the loop executes at least once, then use a do loop. All right, so we have for, while, and do. The last part of this lecture, I want to talk about nested code. So now we've looked at many different nested structures. A nested structure is when you can put code inside of other code. So we've looked at loops, we've looked at if statements, we've looked at try catch. All of those things can be nested in each other. An if can be inside another if. You can have a try catch in a loop, or you can have a loop in an if. We can put loops around or inside a try block, a catch block, an if statement, or other loops. You can have a loop inside another loop inside another loop. When you start to nest code, that's when things really start to get complex. So here we'll introduce variable scope. Variable scope is where in the program a variable can be used, and it depends where the variable is declared. So let's take this example here. Int num iterations equals 5, and then we have a for loop. Int I equals 0, I less than num iterations, I++, and in the body, we're just printing I. Now, given this snippet, if we focus on that variable I, the variable I, which is the loop increment variable, the loop increment variable I has scope only within the for loop. Since I was declared in the initialization of the parentheses, its scope is restricted to the for loop. And recall that when you declare a variable, you are declaring a type and a variable name. So because the int I is inside the parentheses as part of the initialization component of the loop, the scope of that variable I is restricted to the for loop. So you can use it in the parentheses and you can use it anywhere inside the body of the for loop. That is up until the closing curly bracket of the for. If you try to do something like this, if you try to print or use that variable I after the closing curly bracket of the for, you will get this error, cannot find symbol, and Java will point to that variable I after the for loop. So Java is telling you it doesn't know what this I is. It doesn't exist where you're trying to use it. So your program will no longer compile if you try to use a variable outside of its scope. But if you did this, if you declared that variable I above the for, then that changes the variable scope of I. I will now become usable after the for loop. So yes, you would be able to print I after the for loop, but at that point, you might as well use a while loop, since in a while loop, the initialization is outside above the while. You can use I inside the while and after it. But if you're going to be doing something like this, you might as well use a while loop to begin with. How about the variable scope of num iterations? Since num iterations is declared above outside the for anyway, it can be used inside the for. As you can see, it's being referenced in the parentheses, and you can also use it in the body of the for, and you can also use it after the for. We would need to see the complete program to get a concrete idea of what the variable scope of num iterations actually is, but just based on what we're seeing, num iterations can be used inside the for, inside the body of the for, and also after it. Okay, so we can kind of get an idea of what variable scope is. But now, let's see a formal description of it. The scope of a variable starts from its declaration and continues to the end of the block that contains the variable. The opening and closing curly bracket signifies a code block. So we must identify the corresponding closing curly bracket for the block that the variable is declared in. Indentation is important to easily identify those blocks, and variable scope is expressed using line numbers. So let's do a variable scope exercise. Take a few moments to examine the code on the left. The numbers that you see are line numbers for reference. The code itself doesn't make any sense, so don't try to figure out what the code does. That's not the point of this exercise. The point is to identify variable scope, where a variable can be used. So take a few moments and pause the video. Let's do a first example. What is the variable scope of I? We will use line numbers as a reference. Take a few moments, pause the video. What are the line numbers where you can use I? I can be usable on lines 1 through 12. The scope of a variable starts from its declaration, and that would be line 1. I is declared at what's called the top level. The scope is anywhere after it is declared. So it's declared on line 1, and there are 12 lines in this snippet, so we would be able to use I in any of the 12 lines. So we can say the variable scope of I is lines 1 through 12. How about this one? What is the scope of num? The scope of num is lines 4 through 8. The variable num is declared on line 4, so that's where its scope starts. And here's where you need to identify the block that it has been declared in. Num has been declared in the body of the if. Therefore, it can only be used in the body of the if. So that is up until the closing curly bracket on line 8. You will not be able to use the variable num on line 9, 10, 11, 12, and you will not be able to use it after the closing curly bracket on line 8. So only inside the if. Essentially anywhere in the if after it has been declared. So line 4 is where it has been declared, but look at line 8. I have this small square indicating where it can be used, and that is the closing curly bracket of the if. Since num has been declared in the body of the if, therefore it can only be used in the body of the if. Now you see that while loop? That while loop is nested in the if, so you would be able to use that variable num inside the while loop. How about this one? What is the scope of D? And by the way, these variable names aren't very meaningful. I just use them for the example. So what is the scope of D? The scope of D is lines 6 through 7. 6 is where D has been declared, and line 7 contains the closing curly bracket for the while. So essentially, only in the while loop after it has been declared. You will not be able to use that variable D after the closing curly bracket on line 7. How about this last one? What is the scope of F? The scope is lines 11 through 12, or you could say only in the catch block after it has been declared. So you could use F on line 12 as long as it's before the closing curly bracket. So now our programs are going to become more complex, and variable scope is something that you need to be aware of. When I do my examples, I usually declare and initialize all my variables at the very beginning of my program. The reason for this is because it makes it easy to locate, document, and it allows the variable scope to be anywhere after it. If you start to declare and initialize variables when you need to, buried in some nested structure, where you can use that variable becomes very limited. You may actually need to use that variable outside of its scope, so it is best to declare and initialize all your variables at the beginning of your program so you don't have to worry about variable scope. If you follow the coding standard, your code will be organized because you should be indenting your code. Indenting your code properly makes identifying code blocks easier, and the scoping will become more obvious where you can and cannot use your variables. That's going to be it for this lecture. If you have any questions, please let me know.